Welcome to this video. Let's look at R and S configuration. The basic idea behind this R and S configuration is that whenever we have a chiral center is simply a chiral carbon that is attached to four different groups. Let's say R1, R2, R3, R4. This carbon here is a chiral center because it is attached to four different groups. Hence, we use this R and S configuration to, tell us what's the behavior or the configuration of this chiral carbon. That's just the concept there. Is it rotating? Because when you have a chiral carbon, it's always rotating. It can rotate plane polarized light. That's the concept of chirality. Now, is this chiral carbon rotating the plane polarized light to the right direction or in a clockwise direction? Is it going like this or coming like this? Now, that depends on whether it is what R and S configuration. This idea is brought about by three scientists, and they came up with rules known as the Cahn-Ingold-Prelog rules there, simply known as what? CIP rules. Now, the first thing we have to know in this rule is that assigning of what, or let's say assign priorities. Now, that is how do you know the one with the highest priority? Let's say from this man here, let's say we have something of R1, R4, and R. Let's say the R2 is the one with the highest priority. Hence, we will assign the number 1 to the R2. So it will just be R2. Let's say R1 is the second to the highest priority. That is, it has the second highest atomic number. Now, the one with the highest priority will have the highest atomic number. That's just the concept there. So it will just be R2 greater than R1 in terms of what? Atomic number there. So in terms of atomic number, that's what we use. So R3, let's say R3 is the next one, then R4. So that's just the concept there. This is just an example, but we will still look out for an example, a very good example for exam purpose. Now, the second thing is to trace out the paths. Trace out the paths. Now, if you trace out the path, if it is a clockwise direction, then it will be R. R is known as rectus. And if it is anti-clockwise, it will be S. S is known as sinister. That's just the concept there. Now, a very important thing you have to know, this number 3 is just like this 2 is just the basic step. Now, the number 3 is that whenever you see, we have two different kind of wedge. You have the solid wedge. The solid wedge, whenever you see something of this nature, is a solid wedge. Whenever you see that your solid wedge is attached to your lowest priority, let's say in this case now R4 is the lowest priority, hence you reverse the direction. Reverse the direction. Alright? Reverse the, had it been it's actually R before, that is the chiral carbon is R configuration, it's rotating the plane polarized light in a clockwise direction. Hence, and you see that no, the lowest priority there is attached to this chiral carbon through a solid wedge. Hence, you reverse the case. We will look at an example to check it out. Now, another hint we have to know is that whenever you see something and you trace it, you've given them their priority. Let's say you have carbon attached to R1, then R4, R2, then R3. Let's say R1 is the one with the highest atomic number, hence the highest priority. Then the second is the R2, and the third is R3, and fourth is the R4. And after assigning this man here, you have to trace out the paths, and it is not easy because you have your R1 here, you have your R2 here, R3 and R4 are in between. Now where do you go? Which direction do you go? Do you trace it out like this, or you trace it out like this? Now the rule says that you go through the one with the highest number. Between 3 and 4, 4 is the highest number there, so you trace your path like this. Hence this will be what? R configuration. So that's just the concept. So it will be R configuration. You are not tracing, I didn't mean you trace it out like this, will be S, but the rule said that you go through the one with the what? Highest number. Now let's look at an example for us to be very good at naming this. Now let's look at this example here. How do we name this particular compound? Now naming this compound is not a problem, but this compound here, if you can see it, this is under stereochemistry. This compound have a chiral carbon, hence we have to denote or assign a particular configuration to the chiral carbon before naming this compound as a whole. Now if you check it out, this carbon here is not a chiral carbon because it's attached to 3 hydrogen, which are identical group. This carbon here, let's check it out. This man here is ethyl, right? Because CH3CH2 is ethyl. This man here is bromine. This man here is hydrogen, and this man here is methyl. So this carbon here is a chiral carbon because it is attached to Br, bromine, attached to hydrogen, attached to the ethyl CH3 CH2, and attached to CH3, which is the methyl. Now that makes it very interesting. Hence this is the only chiral carbon. Now how do we know whether this chiral carbon has R configuration or S configuration? According to the Kahn-Ingold-Prelog rules, we know that we have to assign numbers to them according to their atomic number. Now we are only considering the carbon, the atoms that is directly attached to this carbon atom. You understand? So let's look at this now. If you check this out, the carbon is attached to CH2 here. This carbon here, this carbon, not this carbon that is here, is attached directly to this carbon here, attached to this bromine here, hydrogen here, and CH3. If you check it out there, bromine has the highest priority because it has the highest atomic number. Then after that, we already know that. So now the second, we already know that hydrogen will be the least. Most of the time hydrogen is the least is the least priority. The reason is because it has the least atomic number, which is 1. So most of the time it will always take the position of 4. But now the position 2 and 3 is between this man here. Carbon here is directly attached to this carbon here and directly attached to this carbon here. They have the same atomic number. Cancel out. So this carbon here is attached to this man here. This one here is not attached to anything. Hence this one has priority over this man here. Hence this one will be our number 2. That's just the concept there. Whenever you see one of the same atomic number, cancel them out and check the atom that they are directly attached to next. Check the atomic number. Hence this one will be 3 here and this one will be 4, because if you compare this carbon here to this hydrogen here, this one will be 3. Hence tracing out the parts, we can see that this is 1 2 3. So that's just the concept. 1 2 3 4. So we just go trace it out like this, and after tracing it out, you can see that this is taking the anti-clockwise direction. And it will be what? S configuration. It will be S configuration. Now let's name this compound. If you are to name this compound there, let's say the IUPAC. So it will be what? 1 2 3 4. That's the longest continuous carbon chain. At carbon 2 we have bromine attached, but this carbon 2 is the chiral carbon, so it will be very good for us to just say 2s, meaning the chiral carbon, it's rotating it in anti-clockwise direction. That's what this S means. And this 2 means that it is in carbon 2. That is, when we are considering the longest continuous carbon chain, we can count it from here 1 to 3. That will be carbon 3, and we are going to take the lowest number, that's carbon 2. Hence you put it in bracket like this. Then the next thing is, what is attached to what are the substituents attached to it? So it will be what? Bromine attached to this carbon. That's just the only substituent. Hence we have what? 2-bromo. So it has to be something of 2-bromo. Then the next thing is to write the parent name, which is butane. So that's just the concept. 2s 2-bromo butane. That's how to name this particular compound. Now let's look at one example, and that's all. Now let's look at this compound there. If you are to name this compound, first thing first, we have to check out, is there chiral carbon here, and the expression of chiral carbon, that is this man here. So that's just it. And this chiral carbon is at carbon 1 because we can't say 1 2. This has a substituent and it is alkane structure, so we have to just start from, so that to give our substituent there, you know, highest priority, because there will be the one that is taking the highest priority. Then we say what? Carbon 1, carbon 2. Hence the next thing is to know the configuration of this chiral carbon. Assigning the rule, this chiral carbon is attached to carbon, chlorine, bromine and hydrogen. Hence bromine will be the highest priority because it has the highest atomic number. The second with the priority would what? The second atom that will be the next highest priority will be the chlorine, because it has the highest atomic number after bromine. Then considering this carbon here and this hydrogen here, carbon will be the third. That's why I say most of the time hydrogen is always the least. Now this is very interesting. How can we trace it out? We have 142 and 132. And if you remember, I told you that whenever we have a case of this nature, we have 1432. We go through the highest number, hence it will be something of this nature. Hence this man here will be what? R configuration. Now let's name this compound. It's because it is at carbon 1. It's either you just say R or you just say 1R. Then you put the bracket. Then you name this compound as a whole. Attached to this carbon here, which is carbon 1 or the chiral carbon, we have bromine and chlorine. Then you can say, okay, 1-bromo, 1-chloro. Then the longest continuous carbon chain, the parent name is eth because 1 2, and that's ethane. Ethane because it only has single bond attached to, the carbon atoms are attached together or bonded together through a single bond. So that's why it is ethane. So that's just how to name this man here, and that's all about R and S configuration. So if, let me give you something to do. Name this compound here. If you have something of this nature, CH2, then CH3. Let's say we have chlorine here, and we have something of this nature here. And we have something like this here. Just name this compound and put your answer in the comment section. You have, first thing first, assign your priority. Then the next thing is to check out the solid wedge. Is it attached to your lowest priority? If no, then you don't reverse the case. So, and the one we've done earlier, the solid wedge is not attached to, if you can see, the solid wedge, the lowest priority is always having the dash wedge, but whenever you see the lowest priority with the solid wedge, you reverse it. Instead of it being S in this case it will be what? R. So that's everything we can talk about on R and S configuration. Do well to click the subscribe button and watch out for more video.